Okay, so now we are going to look at normalization. Now, this is not part of graph theory really, but we'll be using this approach for several other algorithms in this course. So, just want to include this in the first module itself so that we can use this approach in subsequent modules wherever needed. Alright, so what we want to do is given one or more attributes for the nodes in a network. So for example, here we have say a network of 7 nodes, and let us say we are given their weight, height, and say age. So one or more attributes. Now these attributes you can see they are in different units like pounds, inches, and years. So if you really want to compare these nodes based on these attribute values, it's very difficult, almost impossible, or even if you do it, it's going to be kind of erroneous, not really kind of the right way to do it. To just compare based on the absolute values like this, it's not really that easy to do a comparison of these attributes based on the absolute values. So one approach is to do what is called normalization, where we can transform these values in the raw data like this to a normalized scale, to normalized data in a scale of 0 to 1. So we're going to see how to normalize. Again, each attribute is considered independent of the other attributes, okay, as part of this normalization. So we'll do one by one. So, and the same approach is applied to all the attributes. Alright, so this is the approach. So given say what the raw data values, so in this case the weight values, what we'll do is we'll find square of those values and then sum all those square values. So if you sum all these square values, this is what's the sum, 16,572,8. Then we take a square root of this sum, which is 407.1. Then what you do is divide the individual weight values, say 130 by 407.1. So 130 divided by 407.1 is going to be 0.3193. And 150 divided by 407.1 is 0.3685. 125 divided by 407.1 is 0.3070. So that's the idea. So you're going to now get all these values in a scale of 0 to 1 because the square root of the sum is going to be definitely larger than greater than or equal to the individual values. So all these values will be definitely in a scale of 0 to 1, and larger the value here, the individual value, the larger the value here in a scale of 0 to 1, and smaller it is in a scale of 0 to 1. So you're not going to lose any ranking based on individual metrics attributes. So similarly you can do the height, square the height values and then take a sum of those square values. So sum of all these numbers here is 32,600. Take a square root of that, which is 180.6. So now divide each of these values and the height values by 180.6. So 55 divided by 180.6 is 0.3045. 75 divided by 180.6 is 0.4153, and so on. Similarly, you can do for the age, square them, take a sum of the squares, which is 11158. Take a square root of that, it's going to be 105.6. Then divide each of this by 105.6, you'll get this normalized scale. So once everything is in a scale of 0 to 1, of course normalized based on the attribute itself, not in comparison with others, we could now compare the nodes based on this normalized values of the attributes, and we'll use this thing in several other modules in this course, so it's better to know this right away. So let's start with this.